This week on Ghost Hunter Chaser Guys.
This has definitely been one of the most intense hunts we've been on. I'm definitely getting some readings here. Okay. What was that? Whoa, what was that?
It's nothing. It's just me. I knocked over a thing.
Things will be knocked over and mysteries pursue.
Those sounds are pretty weird when we start playing them backwards and slowing them down.
Tune in Saturdays at 8 to see the same shit you probably saw last week on this show. Welcome to the first episode of Johnny Rigged, the show where I show you how to build neato contraptions. I like to call this one the Ghost Meter, or Dowsertron 1000, the Douche Detector, the Awesomeometer. You get the idea. It can be whatever you want. All that this meter really measures is how weak the electrical resistance is between whatever's touching those metal contacts on the sides. So the wetter your hand is, or the more of your hand that actually touches the contacts, the further over the needle's gonna go. This meter is based off a circuit explained by Collin from Make Magazine. I've made some changes though, in order to make this into a more solid device that's befitting of any ambitious charlatan. But to get the idea behind the brains of this device, make sure to watch Collin's kick-ass video first. Okay, so here's everything you're gonna need in order to build this. If you want to use the same ammeter that I did, you can get it from SparkFun Electronics. I also tried wiring this thing a little bit differently and using a voltmeter. It worked, but not quite as good as with the ammeter. If you want the same project box that I got, you'll probably have to get that at Radio Shack. Everything else can be sourced from Radio Shack, SparkFun, the hardware you can get at Ace Hardware. You can see the similarities between mine and Collin's circuit, but I added an ammeter. And I also added an extra LED, which meant that I had to change my resistor value to 145 ohms for those LEDs. I also used a 90K resistor instead of a 100K, and that doesn't really matter. You can use either one. First, you're going to connect a jumper wire to the collector pin of your transistor. Next, you're going to hook up the 90K resistor to that same collector pin and the base pin. Then you're going to hook up a probe wire to the base pin. Next, you're going to hook up the negative pin of your LED that's connected in series to another LED to the emitter pin on your transistor. Hook up the positive lead from the LEDs to another empty spot. To that lead, attach resistors totaling 145 ohms. You might need to play with that value a little bit in order to get the needle to go all the way over to the right, depending on what colors of LEDs you're using. The thing to keep in mind is, don't let too much more than 20 milliamps of current go through the lights. Going too far over that amount can cause the lifespan of your LED to be a lot shorter. So next we'll go from those resistors to the negative lead of our ammeter. Take the positive lead from your meter and attach that to the power rails. Take a 1K resistor, plug it into the positive rail, and then plug that into a probe. Take your battery clip and plug that in. Give the circuit a test by grabbing the probes and see if it works. Huzzah! Those little jumper wire probes are kind of small, so I opted instead for using some C-channel aluminum to act as my probes. You can use whatever metal you want. I ended up attaching a second set of probe wires to a headphone jack. This headphone jack allowed me to plug in some aluminum canisters I had and use them as a second set of probes. To turn this thing on and off, I just put a switch between the 9-volt battery and the ground connection. You're going to need to cut out a 38mm circle from the center of your project box, so you need to mark a center line and then mark where that circle needs to be cut out. You can use a Dremel tool to cut out the circle, or you could use your 1000 milliwatt laser gauntlet, or a drill, but I found that the Dremel seems to work the best. You'll need to make some holes so that you can actually fit the screws on the meter through. I added a third hole on there so I could mount the meter horizontally if I wanted to as well. Those holes need to be a little bit bigger than 1/8 of an inch. You want to make sure that it sits nice and straight, and then you'll have to drill the holes for your LEDs to fit through. The size of these holes might vary, but the important thing with it is that you want these holes to fit the LEDs really snugly, so you have to press fit them in. You want to make sure that your LEDs line up like mine do here, and that way it'll make it easier to solder them together later. You'll want to mark where you're actually going to put your switch on the side, and then cut out that spot. I really like the switch that I used because it has these neat little spring clips on the side which keep it retained really well. Clamp your C-channel aluminum together. Drill some holes in there so that you can actually bolt it to the box. I used a little paper template so I could actually mark with a marker where those C-channel pieces were going to sit, so that they sit the same on both sides. I then clamped those C-channel pieces on there and drilled into the box, and bolted it on with some little bolts. I went ahead and filed down the edges of those pieces of aluminum too. I took a couple of little aluminum cans that I had and turned those into a set of probes by just hooking a couple wires up to them. I made a hole for my headphone jack so I could plug in my other probes into that. The wires from the probes got hooked up to a male headphone jack. I tinned all the pieces that needed to have jumper wires put on them and put the jumper wires on. So the switch needed jumper wires and so did the headphone jack. The LEDs needed to be soldered together and they had jumper wires put on them as well. Hot gluing the wire joints is a good idea to make them a little stronger. This next step isn't necessary, but I thought it was a good idea to put some Velcro on the breadboard. You just want to make sure that you wipe everything down really well with rubbing alcohol before sticking stuff on there. That way it actually sticks on there well. Velcro on the battery is a good idea too, and that way it doesn't rattle around on you. The meter needs a couple of jumper wires, as do the probes on the sides. Okay, let's finish up wiring this thing. Alright, now for my favorite part, deciding what this meter's actually going to measure. I just printed off these tags on my computer on some really thin cardstock. You'll have to take the meter apart in order to be able to size the tags properly, but be really gentle so that you don't mess up the needle and screw up the meter. You can use the meter's original metallic label as a template so that you can cut these things to the right size. It's pretty easy to just slip it in over the top and then just close everything back up. You can cut up an old coat hanger if you want some antennas. I went ahead and added a female USB cable to the end too, in order to bring this into the 21st century. So I can use it with my thumb drive, so I can plug in my cell phone and, you know, run my app, so I can do a little bit of meta-analysis on my the cloud server. Yeah, that's it. Now you can build your own version of Scientology's e-meter, so you can start your own cult, which is a really great way to meet new people and milk them for everything they're worth. I really enjoyed making all the labels for these bogus meters.
These detector, they really work. Only 30 bombs get through yesterday.
Hands down, my favorite is definitely the bullshit detector. It's so ironic. So the moral of this story is, don't believe everything that comes out of mysterious black box gadgets. If you guys have any good ideas for detector labels, make sure to leave them in the comments below. I hope you liked this first episode. Cheers and happy building.
Alpha!